This is Unit 4 on statistics, and this is the first lesson where we are going to be talking about sampling techniques. So we're going to kind of switch gears. I know all of the last 2 units were kind of focused on quadratics, but we will be moving away from that with statistics here. So we're just going to start with a couple of definitions. So a survey is a method of collecting information about a population. A census is something that collects information about everyone in the population. So everyone in the population. A population, on the other hand, is all individuals that belong to a group being studied. Okay, so for example, all students that are taking grade 11 college math. A sample is a group or individuals or items that represent a population. From which they are taken. So, for example, not all students that are taking grade 11 college math, but just this class of students that is taking grade 11 college math. And the last definition here for you is bias. So bias occurs when the results of a survey do not reflect the population. So a study is done, the results come back, and they just simply don't make sense. So there must have been some sort of bias involved. Excuse me. Okay, so the next part of this note, we are going to be talking about sampling techniques. So remember, a sample is a group or individuals or items that represent a population from which they are taken. So sample is basically just a couple of people that come from the whole entire population of the group that you are studying. So there's 6 different sampling methods. So we're just going to work through those so you're aware of them. So the first is simple random sample. So through this, each member of the population has an equal chance of being selected. So for example, if I was, I don't know, giving away a prize and I wanted all of you to have an equal chance of getting that prize, we would do something like putting numbers in the hat, right? Or there's like random generators online. Okay, there's a problem with this though. It's not always an accurate representation of the population. So for example, representation. If I did that and I drew, say I had 5 prizes and I drew them in, every single one of those prizes went to a male in the class, then that might not be an accurate representation, right? There's a chance that everybody that gets picked could kind of have the same perspective or be the same in some way. So the second type of sampling is called a systematic sample. So in a systematic sample, every nth number of the population is selected. So nth is just a variable, okay? So I'm not saying like every 4th, every 17th, every 2000th, but that's what that n represents. Every a number of the population is selected. So for example, if we have 24 students in our class, which actually I think we do, and I want 6 students for my sample, I would just divide those and decide, okay, well, I need to choose every 4th student, and every 4th student will be chosen for my sample. Okay, and just a note here, population is better represented in this case if we had equal people from each gender, right? Because again, we just want to make sure that our samples are not biased and are representative of the population. And in this case, if we're talking about 11C math, obviously there's both males and females in taking that course. Okay, the third sampling technique is called stratified random sample. So with this one, the population is going to be divided into subgroups. So based on maybe gender, age, nationality, etc. And from there, a random sample will be selected from each subgroup in proportion to its size. In proportion to its size in the population. So for example, if we have 16 boys in this class and we want to take a quarter of them, that would be 4 students. But just because we have 4 boys, if we don't have as many girls, we're going to end up taking less girls, right? A 4th is not going to be the same amount of people if there are different amounts of students. Okay, but the more important part there is that subgroup. So instead of just taking a random sample of the whole class, you would break into groups first, and then we would take that sample. Okay, fourth one, voluntary response sample. So this collection contains members of the population who have chosen to respond to the survey. So I'm sure you maybe have had some experience with this. Maybe somebody sends you like a Google form to fill out, and you choose to respond to it. So voluntary means you're volunteering, if you want to think about it that way. The fifth type of sampling technique is called a cluster sample. So a cluster sample is when the population is divided into clusters, obviously, and a certain number of clusters are chosen. Certain number of clusters are chosen. So every member of the cluster is going to be part of the sample. So I break you up into groups, and instead of choosing, instead of like number 3 here, where I choose a certain amount of you from each group, I would break you up into groups and then choose your whole group to be part of the sample, is the difference there. Okay, the last one is a convenience sample. So the sample contains those members of the population from which data is easily collected. So, for example, if we did a survey or a project on the class, you likely would choose students from the class to participate in it because it would just be easier, right? Specifically, if we were in the class, it would be a lot easier. And I'm sure you've done this in elementary school where you were talking about graphs and you took a kind of a survey of your class. So this is the first page. This note is a little bit longer, but it's still pretty straightforward. It's a lot find my words today. It's a lot of definitions. That's not the one I wanted. Where is that? Sorry guys, just hang on. This is the one I want. Okay. So page 2 here. So let's go through some examples. So this first example says a high school vice principal enters the cafeteria and randomly selects 2 tables. All students at those 2 tables are surveyed. So the population here would be all of the high school students in the cafeteria, right? So population, high school students. The sample that he chose were the people sitting at those tables. People sitting at selected tables. The type of sampling. So referring back to that page and thinking about what type of sampling would make sense here. And I think that this would be a cluster sample. So remember, a clustered sample is when that population is divided into clusters. In this case, those clusters would be at tables, and a certain number of those clusters are chosen. And every member of that cluster is part of the sample. So I think that one makes the most sense. So he used the cluster type of sampling. And last question here, is there bias in the survey? Explain. So think about this. When, obviously you're not at a cafeteria right now and you haven't really been all year, but think back to last year. When you went to the cafeteria, you were probably not just sitting at any random table with any random people, right? So you would have sat at the table with your friends, and likely if they're your friends, you probably kind of share the same views. Maybe you take the same classes. Maybe you're more likely to all be in grade 11, right? So there is bias in this table, or in this sample selection. So we're going to say yes. People sitting together are likely friends who have the same views, or we'll say similar views, and are probably in the same grade. If not the same class, right? I know you probably try to take the same classes as your friends. Okay, so remember, bias is when the results of the survey would not represent the entire population. So think about if I just went to the cafeteria and picked the table that you and your friends are sitting at, and I gave you a survey, likely your answers to that survey would not represent someone else. Maybe if you're maybe somebody of a different gender or somebody of a different age. Okay, example 2. A school is divided into 4 groups by grade. There are 300 grade 9s, 350 grade 10s, 270 grade 11s, and 320 grade 12s. Proportion of each group is chosen. So they're taking 10% of each group. So that means there's going to be 30 grade 9s, 35 grade 10s, 25 grade 11s, and 32 grade 12s. So the first thing is asking us, what is the population? So again, the population here is obviously high school students if we just have 9, 10s, and 11s and 12s. So high school students. Okay, the sample, so how many people are being surveyed and who is being surveyed. So that would be 10% of each grade. As soon as I saw that proportion, that makes it kind of easy for me to figure out what type of sample that is, right? So they're technically divided into groups, and then from those groups, a portion is taken from each. So that we learned is called stratified random sample. Okay, and it's asking, is there any bias in this situation? So in this situation, it seems a bit better than the last, right? We've taken all of the students, we've separated them into groups by grade, and then we've taken the same amount of students from each grade, right? 10% of each. So I'm going to say that no, I don't think there's any bias here. It's a fair representation of the population, okay? But if the question was age specific, then it could potentially have some bias to it. But for now, we're just going to stick with no, okay? And this is kind of based on opinion, right? If I asked you a test question, is there bias here? And you said no, and you explained why, even if I thought yes, there is, if you gave me a good explanation of why you thought no, it could still be fine, right? I would still probably give you some marks for that. Okay, last example. So it says, students from Miss Bailey's math class are given a survey assignment. Crystal goes home and surveys her immediate family only. So the population here, it doesn't really say, right? We just know that the math class are doing a survey. Students in the math class are doing a survey. And Crystal decides that she's just gonna interview her immediate family or survey her immediate family, but we don't actually know what the population is, so I'm just going to put question mark. Okay, the sample, so the sample that Crystal is taking here is her immediate family, right? We don't know what her immediate family represents, but we know that's who she's surveying. Okay, type of sampling. Okay, so this one is pretty obvious too, right? Crystal goes home. She goes home every day, right? She ends up at her house where her family is every single day. So this type of sampling is called convenience sampling. Okay, and is there bias here? Absolutely, right? If you're a family, you likely have similar views. That's not going to be representative of the whole population. So yes, family members. And again, it would likely have similar views. We don't really know, right? Maybe you and your family are vastly different, but we kind of think if you're all living in the same home, likely you're all kind of living the same type of lifestyle, so your views would be similar. Similar views. Okay, so let's look at some advantages and disadvantages of each of these sampling techniques, because there is advantages and disadvantages to both, right? So for simple random sampling, okay, that's simple random means basically it's completely random. You might as well draw out of a hat. Okay, one advantage to that is that it's not going to be biased. It's likely that if you do that, you hopefully will get a random mixture of people. Okay, a disadvantage to simple random is that it may not have full representation of a population. So how do I want to write that? I guess I'll just write it how I said it. May not have full. Okay, I'm writing rep for representation of the population. Okay, so it's not biased. Your answer should make sense, but it's not necessarily going to represent the whole population. Stratified random. So that was when we divided into subgroups first and then did random sampling. So an advantage to that is that you're gonna get equal representation, right? Because you've already divided into groups based on certain personality traits or just traits in general. So you're going to have a girl, a boy, somebody who's tall, somebody who's short. It depends what you're looking for, right? But you're going to have an equal representation of all of those populations. A disadvantage to that, to break people into these different subgroups, it might be a little bit more difficult, right? So disadvantage, we're just going to say it's more difficult to do, depending on what your survey is on, right? So systematic, systematic is when we take like every fourth person, for example. So an advantage to that, and I'm sure you've had plenty of situations where your teacher has done this to you, and you probably tried to figure out what number of persons she took or he took, and kind of stand like far away from your friend. I remember doing that. So an advantage to this one is it's easy to do. Okay, and a disadvantage is it might end up being biased. Right, the answers you get, because it's random, you're not 100% sure if it's going to get biased, especially if you're like me and my friends and you tried to get into their group. Voluntary response. So again, this is when you volunteer to answer a survey. So an advantage to this one is if you choose to do it, you're probably getting an honest input or honest answers. A disadvantage is that you might end up with a small population if not a lot of people decide to respond. Okay, so again, you have to volunteer for this one. Clusters, so again, that was the one where we divide into clusters and then we choose a whole cluster to join us. So again, that one's pretty easy to do. It's easy to divide people into groups and just choose a group, but it may end up being biased, right? Because if you break people into group, they might be grouped together with their friends or people who have similar opinions. And convenience, again, that's easy to do, right? If you need to survey people right now and we're in a lockdown, whatever we're in, at home order, you're probably not going to have any other option than to do the survey with your parents. So it's easy, but it could end up being biased, right? Your results might not reflect the population. Okay, so we have one more short page. To this note. Oops. I will try to find the page I want. There we go. Okay. So this is just the second part of the note. So it's two separate documents here. So types of survey data. Okay, so we've talked about kind of sampling and collecting that data. Now we're going to talk about what types of survey data we can have. So the first is called categorical data. Okay, and categorical data is qualitative in nature. Okay, when we see that word qualitative, this is kind of a new definition. What that means is it's descriptive. What that means is that there's not necessarily numbers. Okay, it's more of a description, the data. That data are, well, it says it right there, are types rather than numbers. So some examples could be your favorite color, your favorite sport, what kind of car you drive, etc. Sample survey question. So what brand of cell phone do you use, right? That you're going to give me a description. You're going to say iPhone or Android or whatever. You're not going to tell me like two. You're not going to give me a number. can only be quantified by counting similar survey responses. So it can only be made into like numerical data if we, for example, said 20% of people own an iPhone. Okay, so that's the first type. The second type is called discrete data. So discrete data is quantitative in nature, so that's numbers. Okay, so data that can be counted but has a specific value. So for example, number of correct questions on a quiz, number of green M&Ms in a bag, etc. An example of a survey question could be, how old were you when you got your first cell phone? Okay, so we can analyze using statistical measures. So for example, the average age for the first cell phone is 15. And I bet that's a lot lower these days, but just as an example. Okay, and we'll get more into the statistical measures throughout this unit. Okay, the last type of data is continuous. So continuous is again quantitative in numbers or in value, so that's numbers. It's data that can have any value within a given range or interval. So the difference there is that range or interval. So for example, heights of students in our class, the time you take studying for a test. And an example question, how many text messages do you send in a day? So we can analyze using statistical measures just like the discrete. So for example, 25% of grade 9 students send less than 10 texts, which again, that's probably out of date too. Okay, so here's a quick little exercise for us to do. So classify each set of data as categorical, discrete, or continuous. Okay, so the number of suitcases lost by an airline. So as soon as I see number, I know that I can count out categorical, right? Because categorical is based on a description. So next I'm going between discrete and continuous. So continuous, remember, is when you're given a range or an interval. So for our example here, our range was a day, right? There's no range here, so it has to be discrete. The favorite snack food of moviegoers, again, as soon as we see that it's not going to be a number, we know it's categorical. The length of time it takes for a light bulb to burn out. So again, as soon as we see length of time, that's a given range, right, or interval. So this one is continuous. The height of corn plants. So that's going to be, again, over a period of time, right? The height is going to continue to grow. It's not a stagnant number. So that one is also going to be continuous. The college university students, which college or university students attend after high school. Again, that's not going to be a number. Categorical. The college university students attend after high school. Yeah, okay, sorry, I was getting confused by them. So as soon as we know that's not going to be a number, right, you're going to say, I'm going to Western, I'm going to Guelph. So that is going to be a description, which means it's categorical. The starting salary for people fresh out of college or university. So that obviously has to do with numbers. Specifically, it gives you a time frame, right? It says fresh out of college or university. So that has to be continuous. The time it takes for a car battery to die, again, the time it takes, as soon as we see that, we know that it's continuous. The proportion of tomatoes by weight. So the production of tomatoes by weight. So how many are being produced based on that weight, and that is going to change. So that is also continuous. The monthly spending habits of students, again, those are going to change over time, and it's given you that monthly timeline, so that's continuous. The month in which students have their birthday, so that one could be categorical, right? It's telling you a month. And lastly, the number of students in each Ontario high school mathematics classroom. That's obviously based on right now how many students are in the Ontario high school mathematics classroom, which is obviously none right now, but that would be also continuous because that is going to change over time. Okay, so this is the end of the first note of Unit 4, which is on statistics.